You're welcome to today's lesson. We are on lesson 01 of sequence and series. And before we continue, we need to look at a brief history of sequence and series. There was a man who was a German, a mathematician and astronomer. He lived in 30th April 1777 to 28 February 1855. He was called Carl Friedrich Gauss. He contributed many in the aspect of mathematics and physics, and this is one of his contributions. Okay, so now we have sequence and series. He was asked a question in a class. That is why he came with sequence and series. We look at these things later, but let's look at sequence and series. Okay, so sequence is a collection of numbers or elements arranged in a definite order. So it means that whenever a list of elements is being given, you should be able to continue by knowing the pattern. For instance, if I have 2, 4, 6, I should be able to continue saying this is a sequence. So I should know that the next one is 8. Why? Because I realize that whenever I add 2 to the preceding one, I'll get the succeeding. So when I add 2, 2, 2, I'll get 4. 2 to 4, I'll get 6. 2 to 6, I'll get 8. So I can continue. Okay, let's look at another example. Let's look at this. I have 1, 2, 4, 8, 16. This is an example of sequence. Why? When I multiply 1 by 2, I'll get 2. I multiply 2 by 2, I'll get 4. I multiply 4 by 2, I'll get 8. I multiply 8 by 2, I will get 16. So this is an example of sequence. This is an example of sequence. Okay, so that is the simple way of continuing sequence. So you just multiply this one by 2, you get the next one. Let's look at the next heading. We have series. And series is very simple. Series is just a sum of elements in a sequence. So if this is a sequence, when I find the sum, it becomes series. So let's look at an example of a series. I'm just taking it from the sequence. So when I have this, this is an example of sequence. So series becomes 2, 4, 6, 8. This is sequence, this is series. So in a practical way, we can say that for sequence, they are being separated by comma, but for the series, they're being separated by addition symbol. So we can change this one to series by just introducing the addition symbol. Very simple. Okay, so let's look at types of sequence and series. The first one is arithmetic progression. So we have arithmetic progression. Second one, we have geometric progression. And then the third one, we have harmonic sequence. And then we have Fibonacci sequence. They are very interesting subtopics. Okay, so the arithmetic, normally we call it AP. And then the geometric, we call it GP. And then this is the harmonic and then the Fibonacci sequence. In our next lesson, we'll be taking them one by one to explain. Okay, but as for Fibonacci and then the harmonic, we can just look at it. Okay, so for harmonic, they are used in the music. So for instance, the guitar, that is what they use harmonic for. They use harmonic for guitar. So those who have been playing that guitar, that is the mathematical aspect of music. So even in music, we have mathematics play a role in music. Okay, so for the Fibonacci sequence, it just applied in nature. So that is the shell of a snail. The shell of a snail uses Fibonacci sequence, and then the Milky Way galaxy using Fibonacci sequence. And even the peel of